Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is finding the equation of a circle that passes through 3 points using second method 2. In our previous video, we were discussing method 1, that is using general form of a circle. Here, we are going to apply standard form of a circle. In this method, we will find what is the center and radius and plug them in the standard equation of a circle. Here we go. I have taken an example. We are going to use center and radius form of a circle. Here is the standard form of the circle, where h and k is the center and r is the radius. To illustrate this problem, I am going to sketch the circle with 3 points, given 3 points as follows. These are the 3 points P, Q, R given in the question. We know that if we draw a radius from any point, it will be equal. Am I right? So in case if there is a center, if I connect these points, all the 3 distances will be same. Do you agree with me? Let C be some center. So PC will be equal to QC, which will be equal to RC. All the numbers should be a positive one. Okay. Since radius is equal, we have set the equation. The distance between the points P to C, Q to C, R to C are equal. If you keep this as it is, we cannot use any formula. So I'm just going to take squares throughout the equation so that I can use distance formula here. Hope you are familiar with the distance formula. Let me write that for you. We do not know the C value, the center. So I'm just assuming it to be A, B. Now let's find the distances for PC, QC and RC. P is 2, 1 and C is A, B. Let's apply the distance formula where x1, y1 is 2, 1, x2, y2 is A, B. Since the left hand side is square, you need not write the square root. Now we can apply A minus B the whole square formula. Let's apply this formula for both these. Same way, let's apply the same rule for 1 minus b the whole square. Now open the parenthesis by distributing the positive sign and then combine the like terms if possible. 4 square. So for the second parenthesis, now combine the like terms. 4 plus 1 is 5. So all the other terms are different. We cannot combine them because you cannot add or subtract any unlike terms. So this is the distance from P to the center C. Let this be equation number 1. We are going to do the same thing for the other 2 radius also, for QC and RC. Q is 0, 5. We are going to apply the distance formula and A minus B the whole square formula. Now let me plug in the Q and C values in distance formula. Plugging in the values for x1 and x2, y1 and y2, 0, 5 and A, B. Here we are going to apply the A minus B the whole square formula for both the parentheses. So if you expand 0 minus A the whole square, you will get this. When you apply the same formula for the second parenthesis, you get 5 square minus 10b plus b square. Let's simplify it algebraically by expanding the exponents and combining the like terms. So I'm getting 25 minus 10b plus a square plus b square. So this is the distance for the radius QC. And let this be equation number 2. Given R is negative 1, 2. For your reference, I am writing the formulas again and again. This is the formula for distance and this is the formula for A minus B the whole square. The reason why I am taking the square is I just wanted to avoid the square root because our calculation will be easier. So let's now find the distance between R and C. Let us apply the formula. x1 is negative 1, y1 is 2. x2 is A, y2 is B. Let's apply A minus B the whole square formula for the parenthesis. Same way for the second parenthesis we will get. Let's simplify it. So when you're dealing with negative numbers, be careful with the signs. You just have to remember all the rules of signs. Rules of signs is the basic for all the calculation in algebra. Now let's combine the like terms. Only the constants are like terms. This is the distance for R and C. Let this be equation number 3. We know that modulus of PC the whole square, modulus of QC the whole square, modulus of RC the whole square are equal. The reason why I wrote modulus is because we are calculating the distance. We know that the distance from the center to the given 3 points are equal because they are all radius. Now let me plug in the equations I got for PC, QC and RC. You have to plug in the equations number 1, 2 and 3 here. Plug in second equation, plug in third equation. Please note that we have a square plus b square in all the three sides. So I'm just going to subtract the entire equation by a square minus b square. Okay, I'm going to subtract a square and b square from the equation throughout. By this elimination, our equations will be very simpler and our calculations will be easier. So if the equations are like this, we cannot solve it further. So I'm going to equate first and second and third to make two different equations so that I could use either elimination or substitution to get the values of the center. By equating first and second, I'm getting, let us rewrite the same thing. I'm going to shift all the variables to left hand side of the equation and constants to right hand side of the equation so that our equations will look like a system of linear equation. Subtract 5 from both these sides. Add 10b to both these sides. Hope you are clear so far. Please note that the coefficient and the constant are multiples of 4. So I am going to reduce the equation by 4. So 4 goes 1 time, 2 times and 5 times. Let this be equation number 4. Same as the previous step, I am going to equate these two, the second one and third one, to make a simultaneous equation in A and B. So these two. Let us combine all the like terms. Shift all the variables to left hand side of the equation and constants to the right hand side of the equation. By subtracting 25 from both these sides, we get, by subtracting 2a from both these sides and adding 4b on both these sides, we get, hope you can follow so far. I'm going to reduce the equation by 2 to make a calculation easier, and if I reduce by 2, the coefficients of a for equation 4 and 5 will be same. Dividing the equation throughout by -2, I get. Now you can add equation number 4 and 5 so that you can eliminate a and solve for b. Adding a terms gets cancelled out. Divide both these sides by 5, so b value would be, we have got the value for b. Now you can plug in, back substitute this b value in either equation number 4 or 5. You will get the same value. Replace b with 3. 3, 9. Subtracting 9 from both these sides, you will get the a value. I'm getting a equal to 1. So we got the center. The center of the circle can be found in this way. So a equal to 1 and b equal to 3. So our center is 1, 3. Now let's find the radius. Radius is nothing but the distance between any one of the given point to the center C. We have the center value now, so you can directly use the distance formula. You can use the square root also. I'm going to find the distance between the point P and the center C. P is 2, 1 and center is 1, 3. Distance formula here is, replace x1 by 2 and y1 by 1, x2 by 1 and y2 by 3. Performing subtraction, 1 the whole square is 1, 1 minus 3 is -2, -2 the whole square is 4. Therefore, the radius is 5, square root of 5. From the three given points, we found the center and radius. Now we can just plug in the center and radius in the standard equation of circle. H and K is the center. Here we have used the variables A and B. Center here is 1, 3. R is root 5. On squaring the square root, we'll get the number only. So we use the center radius form to get the equation of circle in method 2. Let us have a quick glance over the solution. Step 1. Graph the points. Assume a center A, B. Step 2. Set up an equation using the concept the radius are equal. Just square them up. We are going to apply the distance formula. Step 3. Find the distance between the first given point and center. Keep center as A, B itself so that you'll be getting some equations. Step 4. Same, apply the distance formula and the a minus b the whole square formula for the second given point and the assumed center. Step 3, Step 4 and Step 5 are similar. Only thing is you'll be using the three given points P, Q, R. So step 5 is using the distance, finding the distance between R and the C. Step 6 is using the same concept. Squares are equal. Squares of the radius of all the 3 radius are equal. So just set up the equations 1, 2, 3 you just got in step 3, 4, 5 here and cancel out the common factor. By equating 1 and 2 you'll get one equation. By equating 2 and 3 you'll get second equation. This should be your step number 7. Eighth step is using elimination method and solving for A and B. So the values A and B is your center. Step 9 is to find the radius. You can take any one of the given point and the center. You just got the answer in step 8 for center. You can use the distance formula and find the value for radius R. Step 10 is finally you have to plug in the center and radius that you got and write your answer in this format, the standard equation of circle. That's it for this problem. In case if you have any query, please let me know. See you in the next video. Have a great time ahead.